In this video, I'm going to talk about the Gauss Seidel method once again. I already made two videos with two examples about the method, so this is actually going to be my third video about the method. It's not that I particularly like the method, but I always think that the more, the better. So the more example we have, the better it's going to be. So once again, let's start with our matrix A as we always do. So our matrix A is this time is 3, -2, 0, -2, 4, 2, 0, 2, 2. So this is our matrix A. Our vector Z, so this is a 3 by 3 matrix. Therefore, we're working in the three-dimensional space, so X, Y, Z. And this is basically why our vector X is X, Y, Z. So we're working in a three-dimensional space. So this is equal to C 1, 4, 4. Okay. So this linear system of equation is actually just 3x minus 2y equal 1, negative 2x plus 4y plus 2z equal to 4, 2y plus 2z equal to 4. So once again, before starting with the iteration, we're going to get the x, y, and z out of variables out of those three equations. So again, I'm not going to solve any of those equations. I'm just going to get the variable out of them. So let's do this. I'm basically going to get 3x equal 1 plus 2y, 4y equal 4 plus 2x minus 2z, and then 2z equal to 4 minus 2y. Again, this is going to give me x equal to 1/3 plus 2/3 y, and y is equal to 4 over 4, which is 1, plus 2 over 4, which simplifies to 1 over 2, x minus 2 over 4, which again simplifies to 1 over 2 z. And then z is equal to 4 over 2, which once again simplifies to 2 over 1, minus 2 over 2, which simplifies to 1 over 1 y. So I just rewrite it. So x is equal to 1/3 plus 2 over 3 y. Y is equal to 1 plus 1 over 2 x minus 1 over 2 z, and z is equal to 2 minus y. Once again, it doesn't actually really make sense to use the Gauss Seidel method for such a simple metric. It's such a simple system of linear equation. I mean, it's really easy and straightforward to do in many other ways. But the idea here is to get to explain how the metric works. And once again, I'll never stop repeating this. This method is actually made for very high dimension matrices and system of linear equation with 27, 30, 50 in the 50 dimension space with 50 variables and so on. But again, I'm going to show you the idea. So we started with the system with a matrix. So associated with the system of linear equation, we basically got x, y, and z, so our variable out of them without solving anything. We just got them in function of other variables. And now we're going to start with the iterations. So our iteration 1, step 1. And again, as I said in the other two videos, I basically say that an iteration as, in this case, 3-step, because I consider an iteration a full cycle for the whole variables. Other textbooks consider the iteration, each step, so it's slightly different, but, it doesn't really make, it's not a big deal right now because, the important is finding a correct guess, and the method is still going to be the same. Just a different of how you consider an iteration to be. So how many iteration you're doing. So right here, I'm gonna write iterations, just like in the other two videos, and values. These are gonna be our values. So generally, the textbook actually gives you, some values to start with. There can be any kind of value. It really depends on what they give you. But in this case, I wanted to show you that the method actually, doesn't actually need the textbook to give you the value, because you can plug in any value you want. And generally, when the textbook or my teacher, my professor, doesn't give me any value, I start with something simple, either 0, 0, 0, or 1, 1, 1, and stuff like that. So it doesn't really matter which value you choose for your first iterations and your first step, because eventually you're gonna get a better guess going on over and over again with the iterations. So yeah, of course, it may converge, sooner rather than later, but it's gonna converge anyway. So okay, so in this case, let's start with x equal to 0, y equal to 0, and z equal to 0. So those are completely made up values. I mean, the textbook didn't actually give me anything. So those are just the values I chose. So for those values here, I'm basically going to plug, find a better estimation of, well, a better first estimation of our x, y, and z values. So x is actually equal to 1/3, which is a scalar, it's not dependent by anything, plus 2 over 3y, so it's dependent by y. So basically say that it's 1/3 plus 2/3 times y, but we said that our guess for y is 0, so 0. And therefore, x is equal to 1/3. Just like that, because this will be equal plus 0, so x equal to 1/3. And we just found a better estimation for 1/3, which is definitely better than 0, okay, so this is actually our first guess. Let's go on. Iteration 1, step 2. So this is our second step. Okay, so values and iterations. So the value for x now is 1/3. Y is still 0 and z is still 0. We gotta find them. Therefore, I'm gonna underline them with a blue pen, as I did in the other videos. So y, I'm gonna get the equation for y. So 1 plus, which is scalar, it's not dependent by anything, plus 1/2 x, so it's dependent by x, minus 1/2 z. So we're going to use the value for z, which is 0, which is nothing, and the newly found guess for x. Therefore, y is equal to 1 plus 1/2 times 1/3, which is the value for x that we just found, minus 1/2 times 0, which is the value that we guessed for x. It's totally made up value. So y is equal to 1 plus 1/6 minus 0. So y is equal to 6 plus 1, and y is equal to 7/6. So this is the new guess we found for y. Okay, so iteration 1, step 3. Okay, so iterations once again, and values. So x is actually equal to 1/3, which is the one we found here. Y, now we know that it's probably equal to 7/6. This is our best guess so far. And z is still equal to 0, because we still have to find it in our first iteration. Okay, so now we're gonna plug in the values that we have. So z, the equation is 2 minus y. So basically z 2 minus 7 over 6. Therefore, z is equal to 12 minus 7 over 6, which is going to give us the value for z, which is 5 over 6. So this is the first iteration that the full step, 3 steps of the first iteration. So we basically have found a new guess for x, a new guess for y, and a new guess for z. Okay, now we can play because we can start for real. And this is going to be our second iteration. So iteration 2, step 1. And now we're going to do the same thing, but with the newly found values. So iterations, values. Okay, so let's just rewrite the values that we had just found. So x was actually equal to 1/3, y was actually equal to 7 over 6, and z was actually equal to 5 over 6, which is the last value we have just found. Okay, I'm gonna underline everything. I'm gonna reload everything because we still have to find all of them again. Because we just started with the second iteration. Okay, so it's kind of fun. X equal to 1 over 3 plus 2 over 3 times 7, 6. If we remember, you know, the equation for x. I'm speeding it up here because, you know, it's the same thing over and again, and already speeding this in the other 2 videos, but so I'm just spinning it up. So 1 over 3 plus 14 over 18, which is just 7 over 9. So this is actually going to give us 9, 3 plus 7, x equal to 10 over 9. Okay, so this is our new guess for x. I'm going to go on again. So iterations, values. So x, our new x is 10 over 9. Y is still 7 over 6, and z is still, well, it's still 5 over 6. Okay, and I'm just gonna, there we go, reload them. Okay, so what was the y equation? Well, it was 1, a scalar, plus 1 over 2x minus 1 over 2z. So we're going to use it to find our new estimation for y. So y, we said that is 1 plus 1 over 2 times 10 over 9, which is our new estimation for x, minus 1 over 2 times 5 over 6. Okay, there we go. So, well, this actually simplifies. This is a 5, this is a 1. Okay, so this is actually 1 plus 5 over 9 minus 5 over 12. Y is equal to, well, is 36. And so 36 minus 20 minus 15. Y is equal to 1 over 36. So this is our new estimation for y. So I forgot to write iteration 2, step 2. Okay, iteration 2, step 3. So last step of the second iteration. So I'm gonna find this iteration. We're gonna find iterations z. Values. Okay, so x is still equal to 10 over 9, y is equal to our newly found value, so it's 1 over 36, 1 over 36, and z, well, we don't know yet, so is 5 over 6, and the last estimation we had I'm gonna underline 5/6. So what was the equation like? Well, very simple. 2 minus y. So 2 minus y, z is equal to 2 minus y. Well, y now is I'm sorry, what was y? Yeah, it was y. Yeah, so y is now 1/36. So our new value for z is actually, well, 36. 36 will be 36 times 2, so 72 minus 1. Therefore, this is 71/36. So this is our new estimation for z. Sorry, z equal to. Okay, so at the end of our second iteration, we basically got x, which is 10/9, full cycle of the second iteration, y, which is 1/36, and z, which is 71/36. So this is basically how this method works, and I hope it helps. And as I said, this video was mainly to show you that it doesn't really matter which value you start with. I mean, your textbook may give them to you just to get the values that make, that are a little bit closer to the good approximation for the resolution of this system of linear equation. But it doesn't really matter if you are, I don't know, in a class and you got to find and compute two or other iterations. You don't have the initial values, just pick something random that helps you through the whole process. So either one, I suggest you either 1 or 0. 0 is totally fine, because by 0 you're going to cancel out a lot of terms. So it's actually going to be, the first iteration is actually going to be way easier to do compared to, I don't know, like multiplying by other numbers and so on, getting weird numbers and so on. And one other thing is that by picking up the values, the initial value yourself, you don't actually have to simplify, because generally textbooks give you values like rounded up, like, I don't know, 0 point something, and therefore you're gonna bring everything you have and round that value up as well. So getting, I don't know, like 2/3, and you cannot write it as a fraction, and so on. So by using yourself your own starting points, so by giving the first get yourself, you're not going to have to round everything up. You can have a nice clean solution which looks like this, and it's way better than the the rounded gibberish trash that you may get when you round everything up. Okay, I hope this helps, and as always, perhaps I'm gonna make another one. Is a third example, but I may make another one. I don't know. I don't actually know yet. Perhaps I'm gonna make it in another video, perhaps not. But just let me know in the comments if you want more videos like this. All right. Bye.